So when we look at this reaction, you can see that whatever the copper lost, the silver gained. The copper was oxidized during the course of the reaction. It lost electrons, and the silver was reduced. It gained electrons. Because whenever you have one chemical is being oxidized, giving away electrons, there has to be somebody who takes those electrons, because you can't just make electrons disappear into thin air or appear out of nowhere. So you can't have one without the other. Because one chemical gets oxidized, one gets reduced. We sometimes call them redox reactions for short. Anytime you have a synthesis, combustion, single displacement, or decomposition reaction, they all fit under this bigger category of redox reactions because all of them either start as elements, ends as compounds, or vice versa. Start as compounds, ends as elements. Elements are neutral, compounds have positive and negative pieces, so your charges would change during the course of any of those reaction types. Double displacement is the only reaction type that doesn't fit under that redox reaction because it starts and ends as a compound. It starts as a positive part, ends as a negative part, starts as a positive part, ends as a positive part, or starts as a negative part, ends as a negative part. So what you're going to be looking for are neutral elements turning into cations or anions, that they're part of a compound, or vice versa, to decide who's being oxidized, who's being reduced. Look for those things that start as an element and become part of a compound, or vice versa. So a little gimmick to help you remember this is Leo the lion goes grr. No, I did not make up that acronym, but it'll help you remember. Leo is going to stand for lose electrons, is oxidation, and Leo the lion goes grr. Grr stands for gain electrons, is reduction. It's silly, but it'll help you remember. So let's say I gave you, this is the net ionic equation for a reaction, okay? So we went through the whole balanced, complete, canceled out the spectators, and this was the only thing left. So if I gave you this net ionic equation and I said, tell me who's being oxidized, who's being reduced, what's going on with the electrons, all that. Let's take a peek. Your iron on the left-hand side is talking about the element iron. We know that because it's a solid, and when you look on the periodic table, iron is a solid. The element iron is neutral. The copper that's next must not be talking about the copper on the periodic table because the copper on the periodic table is a solid and neutral. This is aqueous and charged. The iron on the right must not be talking about the iron on the periodic table because it's aqueous and charged. But the copper on the right is talking about the copper on the periodic table because that's a solid and neutral. All elements are neutral. So when we compare the left-hand side to the right-hand side, do you see how your iron starts as neutral? And then during the course of the reaction, he becomes a positive 3 charge. For that to happen, he must have lost 3 electrons. So if he's losing 3 electrons, that means that our iron is being oxidized. Leo, losing electrons is oxidation. But he loses 3 electrons each. There are 2 irons in our balanced equation. So the first one loses 3 electrons. But then we have the second one losing 3 electrons. So because we have 3 electrons being lost for each of the 2 irons, but we have 2 irons, we're going to have 6 electrons lost overall. So where did those 6 electrons go? You can't wave a magic wand and just make them vanish into thin air. So let's look at what's going on with the copper. He starts with a +2 charge on the left, and he ends as a neutral element on the right. If you used to be +2 and now you're neutral, you must have gained 2 electrons during the course of the reaction. You're being reduced. Gain electrons is reduction. But it gains 2 electrons each. There's not just 1 copper in this reaction. There are 3 coppers in this reaction. So the first copper gains 2. Then the second one gains 2. Then the third one gains 2. So that gaining of 2 electrons happens 3 times, and we have 6 electrons gained overall. The overall lost and the overall gained have to equal one another because we're talking about the same 6 electrons. They're just being transferred from the iron to the copper. We are not talking about 12 electrons in total. Let's do that one more time. Let's say this is our net ionic equation. So we did the balance, we did the complete, we canceled out the spectators, and here's what's left. The magnesium on the left must be neutral. If they don't show you a charge, it's an implied neutral. And the zinc on the right, neutral. So when we compare the magnesium on the left, which is neutral, with the magnesium on the right, +2, it had to have lost 2 electrons during the course of the reaction. So we would say our magnesium is the one being oxidized. Loses 2 electrons each, but in this reaction, there is only 1 magnesium. So it's like multiplying by 1, so we have 2 electrons lost by the magnesium in total. Where did they go? If you look at the zinc, he starts as a +2, ends as something neutral. So if he used to be +2, now he's neutral. He's gaining 2 electrons during the course of the reaction. Gain electrons is reduction. Gains 2 electrons each. But once again, there's only 1 zinc in this reaction. That 1 zinc on the left-hand side turns into the 1 zinc that's on the right-hand side. So it's like multiplying by 1. So we have 2 electrons gained in total. And that's a really good sign when our total lost and total gained are equal to one another. They have to be, because the magnesium is the source of the 2 electrons that the zinc gains.